Hey everybody, so we're back with our last video of the week. We are going to do problems 10-81 to 10-86. I know the stamp sheet says to 91. Just for time purposes on the video, we're going to go 81 to 86. You do not need to keep going to do 87 to 91. This is fine. And the homework is 10-97 to 103. Okay, so starting with 81, and the whole focus of today's lesson is geometric series. So I want to remind you from Math 1 that geometric series is all about repeated multiplication. The geometric sequences and series repeated multiplication. Okay, so we've been working with repeated addition for the last few lessons, and so now we're moving to repeated multiplication. Okay. Alright, so Carlinio is helping her younger sister Julie with her math homework. Julie was given the sequence 10, 50, 250, 1250, 60, 250. She writes the equation t of n equals 2 times 5 to the n and makes the graph it right. Caroline says suddenly, no, you've written the wrong equation. The correct equation is, okay, is Caroline correct? Is the equation wrong? All right. So first, let's get the sequence down. 10, 50, 250, 1250, 6250, ... Okay, and oh, it's not Carlinio, it's Caroline with a typo. Okay, Julie has this. Okay, so Julie's equation was t of n equals 2 times 5 to the n. Okay, so the 5 is the multiplier, and in geometric sequences and series we call that r, the multiplier r for the word ratio. In this one you can easily tell that they are multiplying by 5. If you can't easily tell, you can always find r by taking the second term divided by the first term. In this case, 50 over 10 equals 5. And it doesn't have to be the second and the first. It can be any number divided by the one in front of it. Sometimes when you're working with sequences and series, these are like fractions, and then they get to be whole numbers here. So then just pick two of these, do one on the right over one on the left, and you'll get the repeated multiplication ratio here. So that's just an aside. Okay, so where did this 2 come from? Well, that would be the 0th term. If I were to take this 10 and divide by 5, the number in front would be 2. I bet some of you can see where this is going already. So Caroline's equation was 10 times 5 to the n minus 1. Okay, there's my ratio r. And where's this 10? That's actually the first term. And the n minus 1 balances that out. So the answer really is that both of these equations are correct. You could write it either way. Exactly the same advantages and disadvantages of the arithmetic. This one's nice because you don't have to find the 0th term. So if you don't know it, you can just put the first term. This one's nice because it gives you a y-intercept if you were to graph. But anyway, okay. B. Oh my goodness. What are the advantages of writing the equation as Caroline did? What are the advantages of writing the equation as Julie did? Alright, so advantages of Julie's equation. I just said this. Sorry guys, I should have read ahead. And then this one is okay. C. Rewrite the equation T of n equals 18 times 3 to the n using Caroline's approach. Okay. So we have T of n equals 18 times 3 to the n. Okay, I can tell that this one is like this one because there's n in the exponent instead of n minus 1, so I can tell that this is the 0th term. Okay, so what I'm going to do to get my sequence is I'm going to take 18 times 3 to the 1. 18 times, so 3 to the 1 is 3, 18 times 3 is 54. 18 times 3 to the 2, so 3 to the 2 is 9. 9 times 18 is 162. I don't even need any more than that. Okay, so now that I've gotten the first term, I can write Caroline's equation. T of n equals first term times 3. Oh wait, everybody, hold on, I found it in my bag. Let's see if I can get it to work though. It seems pretty scrapey. Okay. 54 times 3 to the n minus 1. Okay, so now I've got it written in terms of the first term. And you can tell because the exponent is n minus 1. Okay. 10-82. The record-setting lottery jackpot projected. Mr. Hanks? I wish Hank was here. Anyway. Okay. First you have to decide whether you want to get your winnings in one lump sum right away, or if you want to receive them spread out over time. I'm sure one option must be a better deal, but I haven't figured out which one. Okay. When Mr. Hanks gets home, he immediately goes online and learns the lottery winners do have a choice: receive the winnings in a single payment of 51% of the jackpot, or spread payments over 20 years. Okay. Here we go. If he chooses to receive the payout over 20 years, the lottery commission will invest the money for him. They guarantee to pay $1,500,000 in the first year and to increase the amount they pay him by 5% per year. A. If Mr. Hanks wins the lottery and takes the payments over time, the amounts he will receive each year form a geometric sequence. What is the first term? What is the multiplier? Write an equation to represent the terms of the sequence. Okay, so it says they guarantee to pay him $1,500,000. I'm gonna write T of 1,500,000 is your first term, and then multiplier. So this is back from Math 1, if you remember. It says to increase the amount they pay by 5% each year. So what you do is you go 100% plus 5% equals 105%, which converts to 1.05. So you have a multiplier, which we're going to call R in these problems, of 1.05. Write an equation to represent the terms of the sequence. Okay, so since we have the first term, we're going to write our equation like this. So T of n equals 1,500,000 times the multiplier to the n minus 1. Notice we chose n minus 1 because we have the first term here and not the 0th term. Okay. B. If Mr. Hanks takes payments over time, how much will he receive in the 20th year? Okay. So we're going to take 20 and plug it into our equation. 1,500,000 times 1.05 to the 20 minus 1. Okay. 0.05 to the 19 times he will get $3,790,425.29. 3,720. No. Nope. $3,790,425.29. Okay. When you add up the terms of this sequence to determine the total over 20 years, you are calculating the sum of the geometric series. Show the geometric series. Okay. So the first term is 1,500,000. And then, oops, that should be a plus for a series. And each term needs to go up by 1.05. So 1,575,000 plus dot 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 plus, and then we know the last one is this 3,790,425.29. Okay, and just to be clear, this is the first term, the second term, and this would be the 20th term. So this is how much he would get the first year, second year, and the 20th year. With your team, discuss a strategy for calculating the sum without having to calculate and then add all 20 terms. Okay, so we are going to skip that because that's what we're doing in the next set of problems. Okay. 10-83 through 85 are going to be in one problem. And basically what we're going to do is derive the formula for the sum of a geometric series. Okay. And it's going to be challenging. I just want to encourage you that if this problem loses you at some point, that's okay, because the end result is going to be a formula which you're going to be able to plug things into anyway. Okay, so while working on a strategy to solve the lottery problem, Luann's team decides to look at an easier sequence and use fewer terms. They write out the series for the first 6 terms and name the sum of the series S6, then write the equation. Okay, so I have S6 equals 2 plus 10 plus 50 plus 250 plus 1250 plus 6250. Okay, great. Alright, so this is just an example from the book. This is Luann's team is trying to figure out how to calculate the sum of a geometric series. Okay, and I want you guys to think about what we did with Gauss. So remember, Gauss wrote it twice. What we do with geometric series is not write it twice. What we do is we take this one as the original and then we multiply it by the multiplier. Okay, in this case the multiplier is 5. So what I'm going to do is 5 times S6, and really what I'm going to honestly do is multiply each one of these by 5. So I have 10 plus 50. I want you to notice that I am getting the next term just one spot earlier. Okay, so all I've done is I've taken this example that Luann's team came up with and I multiplied it by 5. I picked 5 because the common ratio, the multiplier, is 5 in these problems. Okay, and then what I'm going to do is subtract the original one. I want you to see what happens here. Okay, so this side is 5 minus 1, so 4 times the series. Okay, and I want you to notice this is the most important part of this piece of the problem. I want you to notice that this kind of diagonal cancellation happens out because I'm subtracting. So 10 minus 10 is 0. 50 minus 50 is 0. 250 minus 250. Okay, and it gets me all the way to here. So the only things that are left are these two things. So this is, and I'm going to write this in a very specific way. I want you to see how I'm writing this on purpose. This is negative 2 plus 31,250. Okay, I could have written 31,250 minus 2, but later on I want you to see when I do this in the general formula, I want you to see where that negative 2 comes from. So that's negative 2 here plus this. Okay, so I have 4 times S6 equals 31,248 when I combine those, and then divide by 4. And the series sum is 7,812. So if I were to take this plus this plus this plus this plus this plus this in the calculator, I would get 7,812. Okay, you're sitting there saying, oh my gosh, Miss Hyde, what the heck? So instead of just typing those 6 numbers in the calculator and hitting enter and getting this answer, you're telling me I have to go through all this. No, I'm not. What I'm trying to do is show you a concrete example. For in a moment, I'm going to do this with a formula, and we're going to see how to derive the formula for any sum so that you don't have to do that in the calculator. So that's going to be tricky. So I wanted to show you a concrete one first. Okay, we're going to repeat this process, except for that we don't know when this one ends. So we're going to use the same sequence here. It's a series. 2 plus 10 plus 50 plus 250 plus dot 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 plus. Okay. Now what I'm going to do is I'm going to write the formula here because I don't know when it ends. So it's going to end with, it's going to be, each end increasing is going to plug in here. I'm going to write the formula in terms of the first term. Okay, so the first term is 2, multiplier is 5, n minus 1. Okay, so this is the general form of this series, just doesn't know where it stops. It doesn't stop after 6, it stops after n. We don't know what that is, so writing it out forever. Okay, now we're going to do this exact same thing. So instead of this ending at 6250, I'm ending here. So we're going to take 5 times this guy. Okay, notice you get the same numbers. And then what I'm going to do here is I'm going to do 5 times 2 times 5 and minus 1. So I did 5 times this, 5 times this, 5 times this, that would be there. Okay, and then 5 times this is 5 times this. Okay, then I'm going to subtract the original. Exactly the same thing I did here. So I have 2 plus 10 plus 50 plus 250 plus, then I have 2 times 5 to the n minus 1. Okay, draw my line. Okay, right here is where I'm about to lose some of you, but please try to focus on this diagonal cancellation. When I did it with a concrete example, notice this and this were the only things that were remaining. Okay, so 10s cancel, that's easy to see. 50s cancel, 250s cancel, and then I need you to see that this would exist right here in front, and that would cancel. We didn't write it, but it would be there. Just like the 6250 is there, this would cancel. The only thing we had left was this and this. The only thing we have left is this and this. Okay, 4 times the series equals, okay, so what do I have left? I have this -2 left, so this is why I put it in this order last time. And then I have plus this thing, 5, 2 times 5 to the n minus 1. Okay, and then divide by 4. Okay. Oops. Thank goodness I found the way out. Okay, we can't go any further than this because we have a variable in the problem. So this is the sum of this. It's the formula for the sum of this at any spot. 2 spots in, 10 spots in, 40 spots in. Okay, what I want to do is look at where these numbers came from and try to match them up with symbols to make a formula. Okay, now I think it would be easier if we switch some of these things around a little bit. So I want you guys to take a look at this as a whole. Okay, so let me mark it. This piece right here. Okay, what I want you to see is that this is this number right here, which would be equivalent to 2 times 5 to the n. Okay, so if I took this 5 off, I could write it back in terms of the 0th term. Okay, so -2 plus 2 times 5 to the n. Okay, so this 5 gives you another 5 here, which gets rid of that -1. Let me say that again. This 5 gives you another 5 here, which gets rid of this -1. And then we're going to rewrite this a little bit prettier. Okay. All right. Where did the 2 come from? The 2 is the first term in the sequence. Okay. Times 5. 5 is the common ratio or the multiplier to the n, so that's how many terms we're going out. Minus 2 minus the first term again over 4. 4 was from here, which is 5 minus 1, so it's the ratio minus 1. Okay, so t of 1 equals first term, r equals ratio or multiplier. Okay, now in number 86, I know that was hard, you guys. In number 86, we are going to practice this, so just using the formula. We have t of n equals 30 times 1.2 to the n minus 1. Okay, now notice this one is written in terms of the first term because you have n minus 1 here. Okay, so what we're going to do is plug in the formula. So we know t of 1 is 30. This is the first term. I can tell it's the first term because that's written in n minus 1. The ratio, the multiplier, is 1.2. And the problem told us to sum the first 37 terms. So n equals 37. Okay, I'm technically skipping to B. A is just a repeat of writing this formula. Okay. And so I have the sum of 37 terms equals, okay, so following the formula, t of 1, 30 times r 1.2 to the n, 37, minus t of 1 all over r minus 1. Okay, now let's talk about order of operations in the calculator just for a minute. So I would do the top and bottom separately with parentheses, 30 times 1.2 to the 37 minus 30 divided by 1.2 minus 1, and I get 127,434.34. I want you guys to notice here that this answer is a decimal. That's okay. It's not weird. Notice your multiplier was a decimal, so that means that the numbers in the series were going to have decimals in them, and that's okay. And it says C, we have like a challenge problem, but we are going to skip that. For time purposes, this is it for now. If this is all a lot, focus on getting this stuff, plugging it in, and getting an answer. We will be doing notes on this in the next video. Thanks, guys. Talk to you soon.